Amy, thanks everyone at Hack in the Box. It's always a great conference to be at, and it's always a cool city to hang out in. Every year, year after year, you guys tolerate me on the stage. So here I am again, once again for another hour on some of the kind of tricks that I've been working on recently and trying to make sense out of all this security stuff. Of course, also trying to stay into a job myself, given the situation of this year. Right. So, quick introduction, what are we going to talk about today and what I am going to be doing for this next 1 hour. This talk is mostly going to be a collection of tricks on how to take all your common exploits or uncommon exploits, how exploits have changed, how the whole process of exploitation has now moved forward, given challenges like DEP or ASLR or different things coming in and stopping us. We have to always find new ways to evolve. So one thing I'm going to show is what's the evolution in part of exploits go, what are the avenues open to us. With this, how can we mass multiply our attacks? How can we quickly add up numbers and grab control of as much stuff as we can? Basically, for those of you guys who were in the other talk when Fyodor and Grug were talking about rubbish Russian stuff, I think personally they made up the entire talk, but if what they say is true, and I know that it's true, they're really good friends. If what they say is true, botnets are being sold at $80 a day. You can buy a denial of service attack for $80 a day and take down something like Twitter. You can, rent credit cards, get passports scanned and whatnot. Now, how would you, let's say you want to offer these services, right? Yeah, run your own DDoS network for $70 a day and undercut the Russians. How would you go about doing that? You need to get a botnet, right? How the hell are you going to get a botnet? Well, I'll show you how. So, what we're going to do in this talk is figure out how to assemble large number of computers together and control them. Quick introduction for me, just type Saumil in Google, that should be enough. Hit I'm feeling lucky and it will work. For now it will work. Right. So, coming to the topic of the talk, we're talking about world domination. We want to be on every computer, on every desktop. Same statement as Bill Gates made, right, when they started Microsoft. So how do we get onto every computer in every desktop? Before we do that, there's 4 areas that we need to understand and we need to look at. First and foremost, evolution. Never ignore this word evolution. Human evolution, technical evolution, evolution of processes, styles, culture. Evolution affects us all. Then we're going to talk about a little bit about what the next attack ecosystem looks like for this year and probably for the coming few years. How is the attack scenario going to look like? What are the fertile areas of attack and how can we continue capturing desktops? All depends on a lot of factors like what's the popular software out there, how do people use the internet, or what kind of desktops do they own, what are their habits, what kind of protection mechanisms are there. So we're going to talk about all that. Then what we want to see is how can we take our exploits and mass manufacture them, add them up rapidly and start capturing computer after computer very quickly. I mean, one thing that computers are really good at doing is doing repetitive things really fast. They don't get bored. Right. So coming on to evolution, a few trends that have shaped over the past few years. We'd like to point out specifically 4. Take a look at software. I mean, see how complex software has become. We've always been saying that, right? We've never seen software get really simple. People want to mash up everything. I mean, today, people want to be able to tweet and have their tweet location registered from Google Maps. They want to have their pictures integrated and do whatever they want. It's all about bringing everything together with a click, and that they want to do it from their phone, sitting on the toilet. So yeah, sure, software is going to be pretty complex, but on the facade of it, software looks really simple. I mean, look at Google's interface. It's just one field, you type stuff and it does stuff, and behind it is a complex beast. What are the chances that you're going to make mistakes when dealing with such complexity? Let me ask you this question: let's talk about secure coding for a bit. Right? I mean, people like me have been preaching secure coding for years. There's an old friend of mine, Pallav, sitting over there. He used to work with me. He and I have been teaching classes and trying to drum it into people's skulls that, if you don't use string copy, you're like screwed, and man, you're doing select statements with addition signs. Like, how lame, how pathetic, grow up. Okay. For a moment, sit on the other side. Be a developer. Try to think, how easy is it going to be to write 100% secure code? It's not. The reason why I'm saying this, because last year we had to suffer a development project. 8 years we spent in breaking web apps. Last year we had to build one, and I said, like, screw it, never again. Even if it's a lot of money, I don't want to build a website. Because I'm continuously threatened that what if somebody does this or that. First of all, very little documentation is available. To be very honest, the only really good source of enterprise-grade documentation comes from Microsoft. It's MSDN. Nobody else does a good job of documentation. So how do you code? Cut and paste things and mash it up. Use APIs. Now somebody has a problem, something's broken, so everything you've built on top of that is broken. Things keep on changing. There are some defensive trends coming in, but then the mistakes surmount the defenses always. Despite libraries, despite static code analyzers being plugged into your dev environments and QA and unit testing, there'll be some goofball who will always make a classic mistake on top. And this classic mistake is universal. It's not like, even Google can make mistakes. Harun and I are both witness to a Gmail flaw, which they didn't patch for over a year. I think both since post and we found it and kept being exploitable for over a year, and even Google didn't patch it. Anyway, coming to user awareness. User awareness is rapidly sinking. Users don't have a goddamn clue what they're doing. They see a button, they're going to click it. What they see is what they believe. This is true. It's very easy to make users do whatever you want, right? Lastly, I do want to talk about standards. The quality of standards. It started improving, but until like 2002, 2003, things were halfway stable. Then the quality of standards started sinking. First of all, why the hell are we still at HTTP 1.1? When did this damn protocol come up? Came up in a nuclear testing facility underground below 3 countries in a ring, right? When was this built? 1990 something? I don't know. Protocol has moved only to 1.1. And what are we doing with this old, idiotic, stateless, and asinine protocol? We're running our internet banking on it, we're twittering on it, we're iPhoning on it, we're whatever the bloody helling on it. We're doing everything on a protocol that was never meant to do this stuff. On top of it, you have anybody looked at HTML5? If there was a more ass-backward standard than HTML5, show it to me, and I'll definitely buy you a drink. The standard is around like hundreds of pages long. I was looking at the number of JavaScript events. There's more than 400 different JavaScript events. There's like, did you move your mouse left? Yeah, there'll be an event for that. Did you breathe? There'll be an event for that. There's got tags like canvas tags have become increasingly powerful. You can embed codecs and run things right in the browser. So the path to exploitation is going to shorten up for sure. There's all sorts of talk about, oh, this whole same domain, same origin policy is really bothering us. It's not allowing us to mash up everything. So we are going to implement mechanisms which are going to selectively do away with same origin policies. Now these things, I guarantee you, have not been thought through properly. And sooner or later, there's going to be mistakes made. Like Harun said in his talk yesterday that, a few years ago, we used to poo-poo XSS, like, oh, cross-site scripting, what the hell, it's just popping up alert boxes. But now we know that simple attack vector, which used to be just once, alert document.cookie, now it's become really powerful, and now its impact has sort of grown exponentially. Sure enough, with HTML5, this is going to happen. They're talking about persistent storage. They're talking about online and offline database storage. They're talking about tearaway applications and whatnot. I'm willing to see that. I'm willing to bet that it's going to keep us in jobs for a very long time. Right. So, talking about the attacks and the open attack surface, what kind of attack surface do we have today? So it's all mostly got to do with web. On the back end, it's port 80 or port 443 and whatever that lies behind these ports. So web applications, it's not about the web server anymore. A few years ago, we were talking about exploiting IIS-5 and Apache and Novell servers. Things have moved beyond the servers. Things have now gone into the back end, where that's where all the juice lies. That's where every developer makes mistakes in publishing their web app and bridging old legacy web apps together, and just getting code that runs. I mean, getting it run is a miracle, so you don't bother fixing it up. And most of our pen tests, we do pen testing as a company. Most of our pen tests are app pen tests, and there's not an app that hasn't been broken yet. There's something or the other and gives up the gold. That's where all the juice lies. On the desktop side, all your attack surface is now pretty much limited to just browsers, documents, libraries, media handlers, and any other fancy things you add on top of it, like Java applets, Flash, Silverlight, .NET, QuickTime, whatever you do, whatever elements that you can trigger by loading HTML code or by sharing documents. This is now your attack surface. So in summary, your attack surface is in three common areas. One is you have browsers. Most of our attacks are going to be browser based. And any plugins that the browsers use. We'll talk about browsers a little bit. Browsers are incredibly complex pieces of software. Coming to back-end applications, you have web applications, the business logic of web apps, and databases that lie beyond the web apps. And last but not least is you have documents. Documents, the attack vectors from documents are growing quite rapidly. These are not yet thoroughly explored only because the formats are proprietary. HTML has been beaten up in and out because it's ASCII text. You can read it, you can reverse it, you can read up whatever specs you have and you can learn it up. But it's not very easy to create your own Word document from the command line. You just can't like VI it and write tags and create your own Word document. You need to know how Microsoft implements it. Or you just can't, it's difficult to make up your own PDFs as well. I'll say difficult. It's possible. We'll see some of those. But these documents are rendered by their engines. And what are these engines? Microsoft Office, Adobe Reader, Foxit, or whatever you may have. And soon all this is going to move online as well. So this whole document rendering and all the libraries that are available on documents, That's going to move into the back end. Google Docs, Office Live. What will happen if you have some bug in a document?